Hello there. Couple things about this chapter. Just wanted to make sure you hit some key points to it. The difference between weather and climate, make sure you know the difference between the two of those. Weather is the state of the atmosphere at some place and some time. It's basically what you get. So it's the stuff that's happening outdoors, whatever the temperature is, whatever the humidity is, that kind of thing. Climate is the average of weather over 30 plus years. It's what you expect it to be like. So climate would be long term, weather would be short term. So you can think of it like climate might dictate where you're going to live, if you have that opportunity at least, or maybe where you vacation. Whereas weather is just going to be what's happening then and there, and you just take what you get. So make sure you know the difference between the two of those. Now, describing weather, there's 6 different ways that you describe weather. Temperature, humidity, what kind of clouds are in the air, precipitation, wind speed and direction, and pressure would be another one. Those are ways that you'd actually describe what the weather's going to be like. So those are a couple of key things to remember there. Make sure that you can identify a cold front and a warm front. Warm front's the half circles, cold front's the triangles. Where the triangles point the direction that the front's actually moving. What the difference between a high pressure and a low pressure is. That'll come back to you, obviously, for this entire course. High pressure is sometimes called anticyclones. In the northern hemisphere, they go clockwise and outward, whereas at low pressure will go counterclockwise and inward. And those are sometimes called cyclones. Around here in the United States, we call them highs and lows. In other parts of the world, they're known as anticyclones or cyclones. So make sure that you've got those down, because that'll come back over and over again. A little closer look at the fronts. Cold fronts move faster than warm fronts. It's cold, dense air behind it will move the air ahead of it very quickly. Looking at air masses. Air masses across the world look like this, and we'll get into specific types of air masses and what they do more. For us in Kansas City, we typically see continental polar air masses in the wintertime, just that cold air mass, cold dry air mass we get on top of us, and we'll experience a lot of maritime tropical, which in our case comes from the Gulf of Mexico. It's very moist. It brings all of our moisture in order to get our snowfalls, or when we're talking about severe weather, the two of those air masses, continental polar, maritime tropical, those interacting will cause some thunderstorms. We can get maritime polar air masses too that can bring in some moisture as well. So you can see just across the world the different types. MEs, maritime equatorial. Anytime the M tells you it's maritime, which would mean it's from the water, so it's got a lot of moisture. Anytime you have the little C, that's the continental, which tells you it's a lot drier. The T's for tropical would tell you that it's warmer air. Obviously P, polar, would be colder air masses. So that's kind of some of the things that this chapter kind of just touches on the basis of everything. And then we'll start tying in and really looking at everything, as we go along. One other thing is satellites. There's visible and there's infrared, and then there's a water vapor. Visible is the best to use. It gives you the best detail, and you can pick out, especially for severe weather where you're having, thunderstorms of really tall cloud tops, which would tell you that they're really strong. But the only drawback to that is it's only available when it's daylight, because it's a visible satellite, so it uses the sunshine in order to get the information. Infrared will fill in the gaps, because it can be anytime. It just detects the heat. And so the whiter the clouds, the colder they are, whereas the darker they are, then the warmer they are, which is why the land mass looks like it's more on that black side, because the land is going to be warmer than the air when you see those clouds in the top part of the atmosphere. So infrared can still give you a lot of information. It's just visible has a lot more detail to it. You also got water vapor, which tells you how much moisture is in the air, and sometimes you see it in color, which they would typically use blue for a lot more moisture and reds for lack of moisture, or you might see it in this kind of look where it's black and white, which the whiter it is, the more moisture that's present. real fast, let's take a look at the water vapor for the United States as of this evening, which is 9:42 p.m. on Monday night, the 17th. The purples and the blues and the greens have more moisture, whereas the reds and those orangey colors are the ones at the drier air mass. So you can see right over us right now we have some moist air on top of this, a little bit of a break in between, because all that moisture that you're seeing right there, that was all the rain, and for some of them freezing rain they got this morning. And the next storm system sitting well off to the northwest, and obviously there's some moisture to work with there, and maritime polar air mass moving with it, which is what's going to give us the moisture we need in order to have the snow. If you have any questions on information that's over chapter 1 or anything to do with your investigation manual, which is our lab book, let me know.